Hey guys, today we will continue with Chapter 9. As you know, Chapter 9 is mostly about solving different types of inequalities. We started out with your basic ones, and then we added absolute values. And today we are going to look at inequalities that have two variables in them. So we will cover 2 sections this week, 3 homeworks. Today, tomorrow, and Thursday, and I think that is what I anticipate doing each week for the next few weeks. So let's get started. Alright, so section 921 is... Alright, so far in this chapter we have been solving inequalities in one variable. And here's an example in one variable. You subtract 3, divide by 2, and you graph one variable on a number line. Well, today we're going to progress to solving inequalities that have 2 variables, like x plus y is less than 11. The solution to these types of inequalities are any ordered pair that makes the inequality true. Like in this one, x could be 2, y could be 3, x could be 7, y could be 1, right? There's infinitely many possibilities. So how do we find all of the ordered pairs that we are looking for? Well, we do it by graphing. All we need to learn how to do today is graph an inequality. So, graphing linear inequalities. For an equation, the solutions to the equation are those ordered pairs that are on the line, right? That's what a graph of an equation is. It's a picture of the solutions to the equation. The line has all the ordered pairs on it that are solutions to the equation. But what about an inequality? Well, for an inequality, the solutions to the inequality are ordered pairs that fall in a half plane where the line is the boundary line, or sometimes I like to call it the fence. So your answer might look something like this. You graph the line, and then you shade in whichever side of the line has the answers, perhaps over here. Right? The line acts like a borderline between the part of the graph that has the solutions, where all the ordered pairs are solutions, and the part of the graph where none of the ordered pairs are solutions. All right, so that's what we end up looking at. Let's look at how to graph a linear inequality. Well, you graph it as if it had an equal sign, right, instead of an inequality sign, by one of the methods we already know. Now, usually you just put it in slope-intercept form. I think that's the way most people are comfortable graphing. But later in the chapter, we're going to look at somewhere it is easier to use both intercepts, find the x and y intercepts by putting 0 in for the opposite variables and graphing it that way. But today we'll primarily graph by slope-intercept form. But before we actually draw the line, there are 2 things we need to think about. First, we need to decide whether the line should be a solid line or a dashed line. And here's the significance of that. Going the wrong way there. Dashed lines are for inequalities that have a less than or a greater than sign. Notice they do not have or equal to. And this means that the points on the line are not included in the solution. Whereas, when you have a or equal to, so less than or equal to, greater than or equal to, as your inequality, you make a solid line. And that means that points on the line are included in the solution. All right, so that's the first thing you're going to decide. Should I make the line solid or dashed? And it is strictly based on what type of inequality you have. And then you actually draw the line, and then you decide which side of the line has the answers. So after you draw the line, called the boundary line, determine which side of the line has the ordered pairs that are solutions to the inequality, and shade in that side of the line, the graph. You are shading in all of the ordered pairs that are solutions to the problem. And this is my favorite way to do this, although there is other ways. Test a point. To decide which side of the line has the solutions, because they're all on one side of the or the other, right? We just need to figure out which side of the line has the solutions. We test any point or ordered pair to see if it is a solution. I generally find the point 0, 0 as the easiest point to test, because 0 and 0 are easy numbers to put into any equation. The only time you cannot use 0, 0 is if 0, 0 happens to be on the line, and then you would need to pick another point. So if you pick 0, 0, if it is a solution, shade the side that the point is on, right? Because all the points on that side are solutions. Whereas if the point 0, 0 is not a solution, shade the other side, because that must be where the solutions are. Let me show you a quick example, although the last example is the best one. But this one should be relatively easy, right? So the first thing I do is I act like it's already in with an equal sign. And you guys have graphed equations like this for a long time, right? This number's the y-intercept, the -3, so I'd put a dot there. And the slope is 4, which means go up 4, right 1, up 4, right 1. And I draw the line. Oops, don't draw the line yet, right? Before I draw the line, should I make it solid or dashed? Well, because this has a greater than and not an or equal to, that of course tells me that it's a dashed line. So when I draw this line, I make it a dashed line like that. And then the other thing I do is I'm going to test a point to see which side of this line has the answers on it. And I'm going to pick the point 0, 0 here and see if it's a solution. So I go to my original equation and I put 0 in for y, and I put 0 in for x. And when I simplify both sides, 4 times 0 is 0, minus 3 is -3. I say, is 0 greater than -3? Well, that's true, it is. So the point 0, 0 made the equation true. The point 0, 0 is a solution, which means all the solutions are on that side of the line with the point 0, 0. And I would go ahead and I'd shade in, showing that that side of the line is where these solutions are. Or what some people like to do is, they like to use a highlighter, which is actually a very good way of doing it if you choose to. So your graph is your answer. You get a picture of all the ordered pairs that are solutions to the equation. Let's look at the last two examples and we'll be done. All right, I do this one. It's supposed to be easier, but some people find it more difficult, actually. X is greater than or equal to -2. So if you think about that, that is the equation x equals -2. Do you remember how to graph that line? Remember, when there's only one variable, it's either a horizontal or vertical line. In this case, it's a line where all the x values are -2. And if all the x values are -2, that would look like this. That'd be a vertical line at x equals -2. So I know where the line is going to be now. Should I make it solid or dashed? Well, of course, the or equal to here tells me to make it solid. And again, if I pick the point 0, 0, and I put 0 in for x, and I can't put 0 in for y because there is no y, Is 0 greater than or equal to -2? Absolutely, it's greater than. So again, 0, 0 is an answer, and I would shade the side that 0, 0 is on. And there is a picture of all the ordered pairs that make that inequality true. All right, last but not least, and this is the one most people make a mistake on. All right, so first, what most people do is they don't worry about making this as an equal sign. They just do it mentally, and that's probably okay to do. But I want to get the y by itself, so I'm going to subtract 3x from both sides, giving me 2y is less than 10 minus 3x. And then I'm going to divide everything by -2. And if I was making this an equal sign, I would have y equals -5 plus 3/2 x. And now I'm ready to graph the line, right? It's in slope-intercept form. It has a y-intercept of -5 way down here. It's got a slope of up 3, right 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I'm ready to draw the line. Should I make it solid or dashed? Well, the original inequality is telling me to make this a dashed line. So it's going to look like that. And this is the thing I caution you to watch out for. When you pick a point to see if it's a solution, you want to use the original equation. If you had left a less than sign here, you would get it wrong. If you remembered to flip this because you divided both sides here by a negative, which means flip the inequality sign, now you'd get it right. But my advice is, when you test a point, always use the original problem, and you will never make a mistake. And so I'm putting 0 in for x, and I'm putting 0 in for y, and I want to know if that's less than 10. Well, this would be 0 minus 0, or 0 is less than 10, which is true. So sadly, I wish I had done an example where it was the other side of the line, but I did not. Sadly, this once again is a solution, and so all the solutions are on that side, and it would be over here. Now, if that had not been a solution, I'd be shading in the other side opposite the 0, 0, but I did not. I think that'll be okay for you. Good luck on the homework. We'll talk to you tomorrow.